So I'm starting up my next project. I want to build a power pack for a laptop, something like a MacBook Pro or a MacBook Air or a Microsoft Surface. I'm picturing laptops that are powered by USB Type-C. And the trick is they make solar generators, which are basically big batteries with a 110 volt inverter in them. And I've made one of those on my channel before, but I'm going to do this differently. I am not going to put a 110 inverter in the pack. I am going to use a USB Type-C inverter that can put 60-70 watts out that a laptop can use, and so that we can power and charge the laptop through USB Type-C without having a 110 inverter in the pack. The reason I don't want to use a 110 inverter is twofold. First, a 110 inverter is fairly large. It'll take up a good chunk of this case that I've selected. But more importantly, you'll lose a lot of efficiency. You're going to put a 12 or 24 volt battery in this pack, and then you're going to step it up to 110 volts, which will, you'll probably lose 15% efficiency during the step up. And then you're going to step it, if you plug in the charger for your laptop, you're going to step the voltage back down to 20 volts, which will lose another 15% efficiency. So you could lose 30% stepping up the voltage and then stepping it back up. And, a laptop wants about 20 volts. We can put about 20 volts in this pack. So why do we need to step up and step down the voltage? We'll just use a USB Type-C adapter and we'll make a USB Type-C power bank that can power a laptop. You can find USB Type-C power banks on Amazon, but all the ones I saw were over $100, and they were, if you looked at their rating, they were maybe 50 watts, maybe 100 watts. That's enough to charge a laptop maybe once. I'm trying to charge a laptop 10, 15 times. So we're going to do this big, and we're going to step through the process. Oh, and if you are interested in these kind of projects, please subscribe and hit that thumbs up button. Okay, so first things first is picking a case. And I have chosen this Sheffield, they call it a field box. It's also an ammo case. But it's just a plastic box with a nice handle and sort of a waterproof sort of seal and gasket in the lid. And, it's about the right size to take, 18650 cells. You can see that, cells will stack in there nicely. So we can build a battery pack that fits in here. So this is what I am going to use as my case for this sort of laptop power bank. And so we have our case. The next thing we're going to do is we need to design our battery for this case. Ideally, we sort of want to put as many batteries as we can in here, but we have to be cognizant of any other components that we're going to put in here, and what sort of voltage we're going to build this pack at, and how we're going to, what we got to hit with our battery design. I have already decided I'm going to build this as a 16 volt battery. This will be a 4S battery. Now, I don't know yet how many batteries I'm going to put in parallel. I don't know the total wattage of the battery pack, but I do know that I'm going to build this as a 16 volt battery. Now, why 16 volts? Well, I have ordered a USB Type-C converter PCB board that can take 12 to 20 volts and put out 65 watts for a laptop. It puts out 20 volt. That USB Type-C will put out 20 volts at like 2.5 amps or 3 amps or something like that. and it's happy between 12 and 20 volts. Well, lithium ion batteries start fully charged at a little over 4 volts, and when they're fully depleted go down to 3 volts. So if I put 3 lithium ions in series, fully charged it would be 12 volts, which is acceptable to the PCB, but fully discharged would be 9 volts. That's too low for the USB Type-C converter board that I have ordered. But if I do a 4S battery, 4 times 4 is 16. This fully charged, this battery will be 16.8 volts. And fully discharged, this battery will be 12 volts, which is a perfect range for this PCB, which has an acceptable voltage range between 12 and 20 volts. So this will be a 4S battery. That I know. So now we can, start to play with fitting, seeing what kind of batteries we can fit in here. Now here is a standard 4x5 18650 holder. If I try and put it in this way, it actually doesn't make it all the way to the bottom. Because the sides are slightly curved, I cannot fit it in sideways like this, but I can fit it in this way. So we will have to build so the battery will have to go in the sort of in the 4 across configuration. So if I put 2 of them on there, that fits pretty well in there. Together this is 40 batteries. So I know that I'm going to do at least 40 batteries. The question is, do I want to do more batteries? The reason I say that is, if I here is one of those packs almost fully loaded with batteries. If I put it in there, it fits fine, but there's quite a lot of room sort of at the top here. You can see if I do a side-on view. There's quite a lot of batteries on the top. There's quite a lot of space on the top here. And some of the, the PCB board that I bought for the USB Type-C will only take a little bit of space. And I do have a charging charging port, and I will have, a BMS, but those will not take that much room. So I really think I want to double stack a second battery on top here, because I can put another battery on top here, and it all still fits within the case. So I do think I am going to double stack the batteries in here. I have decided on my battery design here. I am going to put 16 batteries in parallel, and then I will series those up with another 16, another 16, and another 16. That'll be a total of 64 batteries here, and over 600 watts of power here. Just to put that in perspective for you, the average laptop has about a 60 watt battery, and this is over 600 watts. So, not accounting for any inefficiencies, this should be able to recharge a laptop probably 10 times. So perfect if you're going on a camping trip and you need to take your laptop with you, or you need to recharge some equipment, while you're out at the river or out on a camping trip. This will be perfect. Now, if you're wondering what these batteries are, these are 18650 lithium ion batteries. These are LG batteries. These are the M26 editions. So these are 2.6 amp hours per battery. And these batteries are actually recycled out of those Lime scooters that are all over San Francisco and places like that. Those batteries get dismantled and then sold on eBay as recycled batteries. And you can buy these batteries. You can see I have a whole box of them. You can buy these batteries on eBay and reclaim them for other projects. These are perfect for power walls, solar generators, and this big old power bank that I'm building. Recycled, you get them for around 50 cents a battery. Although sometimes you have to break them apart out of bigger packs and out of the original Lime scooter packs and stuff like that. But like I said, recycled, you get them for about 50 cents a battery. Brand new, they're actually around $5 per battery. So Great deal at 50 cents a battery. So at 50 cents a battery, this is only about $32 worth of batteries here. And yet this is over 600 watts of power. You know, I really think that this whole project will be under 60 bucks. And, you know, there's nothing like it on Amazon. So I think this is going to be a cool project. So we got our basic battery layout. Next up will be spot welding the battery and building the battery. And then we'll start assembling things in the package. Okay, now that we know our battery design, it's time to spot weld this battery. You can solder these batteries. I have done videos in the past soldering batteries, but I'm going to spot weld this battery. I'm going to be using this PCB spot welder hooked up to a LiPo battery, and we are going to spot weld these batteries together. This will be our main positive. So the positive will join to this will be the main positive. This will be negative. This negative will join to this positive, and this negative will join to this positive, and this positive will join to this negative, and so on and so forth. We are basically, each section we are joining the positive to the negative, or in this case the positive to the negative. But anyways, I'm gonna go ahead and do this, and I might I'll do a few, and I'll probably time lapse you, and we'll get this battery spot welded together. Okay, let's flip the pack over here. Okay, now this is the other side of that pack. We will not join across like this. If we did, we'd simply be creating a massive short circuit and we'd instantly melt all the nickel. Remember, the batteries are now connected on the bottom. This section needs to stay separate from this section because this will be our main positive, and then this negative will join over basically to this positive over here. So we have to keep these two sections separate, and we'll put some tape down. While working on this section, it's a good idea to cover up the other section because these batteries are now connected behind, and so anything that shorts between these will create a massive short circuit. So anyways, time to put some nickel down, and we will keep building our battery. Okay, these batteries are finished. They are fully soldered. You can see they're bridged on the underside and come out here. So here's our positive. That positive comes down and around. That's a negative. This negative will bridge over to here. That goes down and around. And that'll be our main negative. So main positive, main negative, and we need to bridge these two. So I think let's bridge these two right off the gate. I'm going to do that with solder because eventually I'm going to stack this battery like this. So I just need a bridge wire between these two points here. I need to be careful because when, these are live, and if I ever stack these on top of each other, I am going to short circuit everything. So we're going to have to wrap this in tape and put a spacer between. But for now, we can flow some solder onto these batteries here. Okay, get a little bit of wire. Let me flow a little more solder onto that. And again, we have to be careful here. We're slowly making these connections live. Okay, that's a nice connection. This is a horrible connection. I want to put some more solder or do something on this one. Okay, that's a better connection. Okay, these batteries are connected now. So next up is the BMS. I have my BMS somewhere here on my workbench. Okay, here is my BMS. This is a 20 amp BMS. I am just going to hot glue it down on the board here, and then we will make some connections. Okay, that's hot glued down, and now we can start to make some electrical connections. With a BMS, there are going to be main power wires, and then there are going to be balance wires. And it'll all be labeled B1, B2, B3, and it normally starts from the negative. And then, so in this case, that's B negative. So this will be your main battery negative, which is actually that over there. So this will have to connect over to here. But again, these are going to be stacked like this. So I can just have I can have a wire that sort of runs over to there. It'll be fine. And then battery negative, then battery 1, battery 2, and battery positive. And then these are actually the outgoing connections, which will go over to the USB PCBs. So anyways, let's wire some of this up here. Let's get a little bit of wire and wire this. Okay, this BMS is active, and actually we should be able to put a multimeter on here and check if we have voltage from the BMS. Let's see. Yep, 16.42 volts, which is perfect. So here is the battery. It is built. This should fit nicely in the box. I'll probably put a little tape around these to connect them, but they are ready for the box. Okay, I received in the mail the USB PCB that I was waiting on. This is from USB Gear, and this can take 12 to 20 volts and output 65 watts through the USB Type-C and another 18 watts through the regular USB. This is going to be mounted in the case over here. As you can see, it's a bit of a tight squeeze with the battery. So, and it actually came with this, with these screw terminal adapters, but with that on there, I kind of ran out of space. So I've removed the screw terminal adapters, and I've actually soldered a couple leads directly onto the PCB power traces, and I'll wire this up using these, but that just gives me enough space so that I can mount this in the case, and we'll go from there. Okay, let's talk about some of the other components you are going to need. You are going to need a charger. This is a 16.8 volt charger at 1 amp. It has a barrel connection. This is a center positive barrel connection. This is the matching barrel jack, and these two will plug into each other. And this will be mounted on the case, and you can see I have wired the center pin for positive. Some of these adapters, sometimes the center pin is negative, sometimes the center pin is positive. Most commonly it is positive, but you look at the diagram here and you can see it's telling us that the center pin is positive. So this barrel jack is wired as positive, and we'll go back to the battery to charge the battery. We also need a switch. This is just a high amp switch, and we'll need another XT to connect into the battery, and then we just need to put it in the case. You can see I've already mounted the USB PCB with a piece of wood. The reason I use that piece of wood is it allows me to put a couple screws into the front to hold it in place securely, since that PCB has no way of mounting it on the panel directly. Okay, I have finished the basic wiring. You can see I have the regular USB, the USB Type-C, that's mounted onto a little board that's then held in with these two screws. I have my barrel connection for the charger, and I have my on-off switch over here, which you can see when it turns on, you can see the little red USB powers on there. Turn off, and that turns off. And then we have our, this is our charging port, plugs in here, and that charges the battery back up, and when you're done we can cover that up. So we are done with the front of the case. Let me quickly show you the wiring on the inside. You can see all the wires come to this XT60, which connects to the battery. The power wire, I have one power wire which runs down through the switch and then back out of the switch into the board. There's a ground which runs directly to the board, and so that power through the switch completes the circuit and powers the USB when the switch is turned on. There is a second ground wire which runs down to the switch because the switch needs a ground to power the little LED on the switch. And then I have a positive and negative going directly to that barrel port, so that when I plug in the charger, that energy runs directly into the battery. So yeah, the wiring is complete. I'm going to stick the battery in here. I just need a little bit of a tie down mechanism so that the battery doesn't slide around in here. But we are done, and I'm just going to assemble the pack and we'll do a test. So here is the finished pack. You can see it's nice and clean. There's all our ports on the side. Again, power button, charging port, and then the USB Type-C and the USB 3.0. Here's the inside. Ultimately, I realized I don't need any sort of tie down for the battery. What I did is I stuck some packing foam around the battery, and that is a wedge fit now. That piece of packing foam made this battery a complete wedge fit into the pack, so that battery is solid, not going anywhere. And again, here's our XT connector into the electronics, and the battery is finished. And let's switch to the other camera for some testing. Okay, let's test the pack. First, let's do regular USB, turn it on. Let's plug in the regular USB. I have it hooked into my tablet over here. And the meter, you And you see that? The meter says we are pulling 1.2 amps at 5.25 volts. Perfect. And the tablet, yep. Tablet is dead, but charging. So yeah, that's good. So the regular USB works just fine. Now I don't have a meter that can test the USB Type-C, but for now I'll just use my phone to check that the USB Type-C is working. Okay, here we go. Yes, charging. Okay, so the USB Type-C works as well. Again, this USB Type-C is rated for 65 watts, which is plenty to power a laptop, not just a phone. And your regular USB is rated at 18 watts. It's together they're rated for 85 watts to concurrent. So yeah, this pack is more than capable of charging a laptop about 10 times, and is not too big or too heavy, and you know, perfect for a camping trip or a road trip or somewhere where you need portable power for, you know, laptop, phones, anything USB Type-C.